Okay, after much deliberation, we are, and apparently 7 extra speakers, we're ready to start Codename Stiltwalker. This is brought to you by DC949 and friends. And you may notice that talk details are quite sparse in your programs, so I suppose I can't give you much more information than what it has there, but much fun will be had. So, take it away.
Hey guys. So, bit of an interesting thing that happened today, and we'll get into that. But this is our Stiltwalker talk. We had a lot of fun doing it, and we've got the rest of the crew up here just to hang out and have drinks with us. And we really hope you guys enjoy this as much as we did, and let's get it rolling. Go ahead. Oh, I gotta hold it up to the speaker, because, you know, we don't know how to have microphones.
Cup.
There we go. Start over.
Vote 8. 4. Carry. Wednesday. Cup.
Does anyone recognize what this is? It is a reCAPTCHA. You are absolutely 100% correct. Go back. So, go back. Thank you. I'm a little drunk because, ding. So, right now, at the very bottom, we would actually start a very interesting application. But as the next slide, we're about to tell you that, ding. As of 2 hours ago, we got countermeasured.
Like an hour before our talk. An hour before our talk, it changed.
Yeah. So right now, there's a really shitty version of audio reCAPTCHA that even humans have a hard time solve. If you haven't figured it out, Stiltwalker is a reCAPTCHA beating system. And a very interesting timing that we got countermeasured just before our talk. So kudos to you guys. We were going to put the ball in your court, and you put it back in ours. So we're going to go and have fun with this, give the talk as we planned, and then go over some of the things that they fixed today.
Fuck you, Google. Fuck you.
Ding. Who's that? That's me. So, is anyone not familiar with what a CAPTCHA system is? Because I'm going to be really surprised, but we won't haze you, I promise. Well, I mean, you're British, and you're wearing a Burger King hat, and you're Russian. So at least the third one should know. Fuck! Hang on a second. No comments from the peanut gallery without a microphone. So everyone's familiar with what CAPTCHAs are, so we can just skip this fucking slide. Why reCAPTCHA? Good question. Not so much relevant right now anymore, but fuck it, here we go.
I got my own mic.
It's not working.
It's not working?
Ding.
Oh, yeah.
It's not working. So you need this mic.
All right, pass the mic, my friend.
All right, so at ShmooCon, there was ice. Yeah, ice. Okay. At ShmooCon, there was some vendor who had some contest where you win a Kindle Fire or an iPad or some shit like that if you tweeted something and had the most followers. So we were like, okay, well, how do you make followers? You make an account, you make it follow you, and now you have a follower. So if we can do this more times than other people, we'll win. And that's how Jeff Ball and I got started with we're going to reCAPTCHA because Twitter uses reCAPTCHA to create accounts. So you create an account once, works fine. No reCAPTCHA, just you're good. You create another one, okay, fine. You create a third one, it's like, you know, I think this might be a bot, so I'm going to make you solve a reCAPTCHA. And we're like, all right, well, we just need a script that can also solve reCAPTCHA, and then we're good to go, right?
Yeah, that's all we have to do.
Yeah, so, I mean, so we're like, all right, well, let's just do that. And we spent, 8 hours or so at ShmooCon working on that. Didn't work out so well, but we were making progress, just wasn't there. CP had a different motivation.
I had recently left Maryland and moved to Virginia, and I was kind of bored. I'm like, what can I fuck up that's not boring? Oh, reCAPTCHAs, and they probably planted the seed in my mind when we were at ShmooCon. So somewhere, subliminally, somewhere in my mind, reCAPTCHA was floating around. I'm like, all right, reCAPTCHA sounds like a fun thing to fuck up. Let's fuck it up. start digging into it, find some fun things, and I hit up Adam because this is the guys I like to work with, and they do really good work. And I found out that they were also still working on it. So we joined forces, and Codename Stiltwalker was born officially, and we started working on it. Ding. Lexicon. How many words are in audio reCAPTCHA? 58. In different groups, well, was in reCAPTCHA. 58. Colors, numbers, vehicles, all kinds of things. And that's it. You have words and you respond with words. That's how CAPTCHAs work. 58 is not that big of words. There's I think it goes over that somewhere else, doesn't it? I'll do it now. There's 6 words total that it says to you, and you have to respond with 5 out of 6 correctly, and then you win that CAPTCHA. So, yay. One of the reasons is for humans, because sometimes we're dumb and can't figure things out. So, you may have seen the 3 of us wearing some weird shirts last night that had some of these words written on them, and that was just because we were bored and wanted some shirts to screw with you guys. These are strange one-off words. We don't know what these are, and I'm sure there's a reason for them, but they don't match anything else, and they only come up in maybe 1 out of 5,000 CAPTCHAs. Really peculiar things. If you want to play the first one.
Listen to the 3rd word.
Cup. Green. 8 Christmas.
So 8 Christmas doesn't really match anything, and the word 8, and it's one word. It's because we know there's only 6 words that come out of the system, and even with 8 Christmas, there were 7 words if you chop up 8 Christmas. So we assume that 8 Christmas is one word. It does not actually validate on 8 Christmas or 8, so we don't know what it is. Some kind of interesting relic. There's some other weird things that we found, and we'll play this real quick.
Glycol white. Glycol white. Red line purple. Red line purple.
So I don't know if you've ever listened to reCAPTCHA, closely. There's the foreground noise, which is the words that you want to, get, and then there's the background noise, the kind of background radiation to screw up bots from being able to figure out where the word is. Just take a listen to this and see if you can figure out what this is.
Boat. 8. 4. Ferry. Wednesday. Cup.
So it's a little bit quiet with this, but did anyone figure out what the background noise was? Well, I mean, too human for that. Yeah, we can play it again. Why not?
Boat. 8. 4. Ferry. Wednesday. Cup.
Anyone?
Is it just backwards?
Backward speech.
Yeah.
Nailed it. So really interesting. So now we're going to reverse the whole audio and now listen to the background speech again.
Yes, no. Hear it. Hold.
So you might have heard it. It says something about struggling to stay open. We actually spent a lot of time listening to those background samples, trying to figure out where they came from. Turns out they're radio broadcasts that Google chopped up and used 3 at a time. So there's 3 distinct different samples being played in the background for the noise. I initially heard that and went, holy shit, they're using Google Voice phone calls as background. Those assholes! Turns out, not so much, but that would have been great. So radio broadcasts, interesting. Ding. That's you.
So the first thing you got to do when breaking any CAPTCHA really is split it into pieces, because to try and do it all together, it's pretty hard, and there's 58 words. You got to get 5 right, so you're not going to guess that. So you got to split it. But can anyone guess, looking at that image, where these 6 words are? So that's a spectrogram. It's on the x-axis it's time, and the y-axis is frequency. You do a fast Fourier transform to split it up by frequency over time, and the color is the amplitude. The brighter it is, the louder it is. So if you look at that, the background only goes up to about 3.4 kilohertz, whereas the words go up to about 5. So if you just look, you can kind of pick out the words pretty easily. That's kind of a fail on Google's part. Yes. Ding. Okay, so our first our solving technique was to say, okay, let's look at those images. Well, everyone that's chair looks the same, and everyone that's scissors looks the same. So let's get something that looks at images and says whether they're the same. So I Googled for it and found, found phash. Phash is a library that tells you how similar images are. And so, well, just split up the words, solve a bunch of samples, then find ones that are similar. You look through all of the words that are scissors. Does the target one look like that? If it does, you found the word scissors. So on the right there's 4 examples. 3 of them are the same word, and 1 of them is not. Can anyone guess which one's not? Yeah, did C.
If you can do it, why can't software?
Yeah, so A, B, and D are chair, and C is the word scissors. So, yeah, and then we downloaded and solved 44,000 samples. No, 50,000, I'm sorry. 50,000 samples by hand. And then double verified the entire set. So we listened to them 100,000 words, essentially. And then we got the spectrograms of all of them, split them up. And so now you download a CAPTCHA, you split it up, you take each word, and you use phash to compare this spectrogram slice with one of your samples. And then again, and again, and again, 50,000 times until you find the 5 closest ones, and the 5 closest ones are the word. So I'll search for the 5 closest ones in chair, add up the distance, then I'll search scissors, add up the distance, and the one with the lowest distance is the word. And so that's one of the solvers we did. It didn't do as well as the next one. Ding.
So Jeff Ball came up with the phash stuff, and it was working at what, like 30% overall accuracy?
Blah, blah, blah,
Yeah.
blah, blah, blah.
Anyway,
Rebel.
Different slide.
I've been drinking.
No comments without a microphone.
So he had his method, and I had a machine learning class from Stanford. It's a free online class. You guys might have seen it advertised on the internet. And I was like, well, why don't we just take all that audio data, throw it into our network, and just get the answer? I mean, how hard could it be, right? So that's what I tried to do. And so the machine learning is a supervised learning, which basically means the machine can't figure it out by itself. It needs a person there to get it started. And that's what the solving was all about. We had to solve lots of CAPTCHAs to train the computer so it knows what white and black and orange and red line purple, okay, maybe not that one, but all the different words. We need to know what they sounded like, what they look like statistically speaking, from just an audio analysis standpoint. So it doesn't know that the word is red, but it knows that if it looks like this, then I should give you this answer, which is good enough for us. So the neural network is similar to linear regression. So I think that explains everything pretty much, right? Okay. I'll explain what linear regression is. It's actually pretty tough to explain machine learning in 20 minutes. But it uses linear algebra. There's a bunch of matrix math in there, so anyone who's heavy in math at least knows what those words mean. There's not enough time to explain how neural networks work, so I'm not going to try, but yeah. Ding. So this is how neural networks work. Okay, so if you look at the graphic, we have some stuff on the left, a bunch of stuff in the middle, and some stuff on the right. So the stuff on the left is the actual audio file, and it's represented in numbers, basically. So we have how much audio is between 0 and 2.69 hertz, how much audio is between 2.69 hertz and 5.38, and so on and so forth. If you think of it like, how much highs does this have, how much mid-range, and how much bass, like from a stereo concept, it's the same thing, but just with a whole bunch more bands. So it turns out we have 2,048 bands in our example. It goes through and does a bunch of calculations and comes up with some hidden nodes. I'll explain that in a minute. And then it goes from those hidden nodes using the same process to get to the output. So the output nodes on the right are red, blue, all of our different target words that we're looking for. There's only 58 of them, so we have 58 output nodes on the right, 2048 on the input, and so, okay. If you think about the word red when they're saying it, there's going to be a certain amount of bass, a certain amount of mid-range, and some highs. And I have it broken up into, 8 different columns here, 9 columns. So this is what the word red might look like. Not so much bass, a bit of mid-range, bunch of highs. The word blue is going to have a different signature. You have different phonetics there, and you come up with not much bass, a little bit more in the low range, on the mid-range, and not so much on the highs. Green has a different signature altogether. Okay, so this is some word that we don't know. Now, does anyone care to take a guess at what word you think that is, if it's one of the 3, red, blue, or green? Green, you're wrong. Okay, red, yes. And the way you figure that out is it's closest to the red in every different iteration. So, okay, on the highs, on the very high end, it's way far away from green. So that's a big penalty towards green. And what you do there, without even thinking about it, is you're measuring the distance, so the error rate, between what we have and every single different thing that we know about. So what you're going to come up with is, okay, well, it's pretty similar to red. It's not 100% similar to red, but it's pretty close, closer than blue or green. So out of those 3, our best guess is red. And we're going to have a certain certainty to that as well. Oh, drink, all right. Thank you. All right, so the problem is, if every red sounded absolutely identical and there was no background noise, then this would work perfect. We only need one sample. Does it match or does it not match? And we're done. With the background noise, there might be a different amount of bass because you have some backwards word that has some bass in it, mid-range and highs as well. So the neural network basically tries to figure out what does red sound like. And you're going to have a whole bunch of different reds. This is just one example.
Inflection.
Yeah, there's different inflections for each time it says red, so sometimes it'll be like red, red, red. So they're all going to be slightly different, and our machine learning needs to account for that. So how do you draw a line through that to say, okay, this line represents what red is? It might be a little bit different than that based on the background audio. It might be a little bit different based on the inflection, but this is basically it. And as long as you're close to this line, then we know you're close to the word red. So we could just say, okay, just draw the best fit line here, and that, it doesn't go through all the points. I don't think it goes through any of the points actually, but it goes through, and it's pretty close. So that's one way to say, okay, this is the word red. But what if you made it slightly curved? Okay, that's a little bit better fit. That's probably more accurate. What if you made it a little bit more curved? What if you made it really curved? Now it goes through every point perfectly, so your error rate would be 0, right? Turns out that only matches that particular inflection of the word with that particular background noise, which is not terribly useful. So this line probably is not as accurate as the previous line. It matches this sample better, but it won't generalize to other samples as well. So it's a trade-off, right? You don't want to be too dumb about it and have some straight line that, is pretty far off from everything. But you don't want to overfit and have it match this one sample really well, but not match other things that actually are red. So you have to find some kind of middle ground. Turns out, machine learning can do that for us, which I'm all for that. Less work for me, right? So that's what these middle nodes are. These middle nodes are the hidden layer, and each one represents a different line. So one might be really squiggly, one might be less squiggly, and just all kinds of different variations. And the reason they're different is because we just randomly initialize, and then as we train, we get closer to what it should be. And the more we train, the more they're going to converge. And we have to be careful not to train too much or too little, just like the Goldilocks, not too hot, not too cold. And we basically use this process to get from the inputs of sound to our hidden nodes, and then we run the same process on the hidden nodes to get to our output. So we'll have a number of our certainty for, we are 0% certain this word's red, and 3% that it's blue, and 97% that it's kettle, Okay, well then the word's probably kettle, so we choose kettle and move on to the next word. Ding. Backup solvers. Turns out since the machine learning doesn't get it right all the time, but we have a certainty, we can do better than just one set.
So rather than having one solver, well, they're reasonably fast. Why not use more than one solver? So we can have a neural network with 1536 hidden nodes, and another neural network with 2048, and another one that's trained on a different set of samples, another one that's trained on 500 iterations of running through the training, and one that's trained on 5,000 iterations that took a week and a half to train. And so when you, on a quad-core 3.3 gigahertz processor. So it was a long training set that drove us nuts trying to, waiting to see how well it did. But so our current best solver has, best solving chain has 13 different solvers with one p-hash, because I mean there's only one variation, and 12 different neural networks in front of it that solve it, get a certainty value, and then we just pick the highest certainty value. And so we can just...
I have a question. I don't know whether that key word you mentioned in your early slides is part of the standard recaptcha. It sounds kind of weird. It could be. Is that something that you found out by really going through all those samples to get
Yeah. So the question was, is 58 words the standard reCAPTCHA? Well, when we go to reCAPTCHA, there's only 58 words. And we figured that out by doing 50,000 words manually. And so besides those one-off 1 out of 5,000, there's only 58 words. Was only 58 words, sorry. Yeah, fuck Google. But yeah, so another question? No, there's 3 background sets that are used for each sample.
Simultaneously, 3 at a time.
There's tons of them, but they only pick 3 random ones and then play them back. Again?
Sorry, real quick, just to follow up on that. So there was no actual, you didn't mention this, but what was the time frame it took you to get to those 50,000 samples?
Okay, so we solved them in several, we didn't do 50,000 to begin with. We solved them in sets. So the first set was 6,000, and I think that took me like, I don't know, maybe 5 hours of words, or no, and then another 5 to double verify. What?
Another thing, when you're listening to boat, 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 kettle. Oh, wait, let me fix that one. It gets, like, it will drive you bonkers. You have to take a break. Yeah.
You know what I'm saying? I'm just going to double follow up and just hijack what he was saying and hijack what he was saying. Seriously, if you've ever wanted to listen for one word for several hours at a time, give us a call, because like we might work on this in the future, need some more validators. It's maddening. Sitting there and yeah, there's a volunteer. CJ, come on up, join the peanut. Mechanical Turk, that's good. So one of the samples was really tough, and I'll get to you in a second. One of the samples was really tough. Boat is a horrible sample, because unlike any of the other words, boat is very special. Fuck it. Boat, one of the inflections, has a significantly higher amplitude than the rest of the versions of boat. So if you're sitting there with headphones, manually validating a set of boats, you're hearing boat, 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 boat. Ah! So you're sitting there for hours hoping to God you don't blow your eardrums out while simultaneously trying to make sure that you have 100% accuracy in your manually validated samples, because you don't want to throw the neural network off. It needs to be validated. That's what we're doing. So he's right. You take a break maybe once an hour, and then you come back 6 hours later and do another hour, because it's absolutely maddening.
One more question, and then
Why wouldn't you try to extrapolate out your background noise, even with
Ah!
filters?
Yeah, that's
do we have a
the thing.
slide on that?
No, we don't.
Okay.
But that's something that.
That's a CP.
Yeah.
Yeah.
You're not using a
Okay.
per sample, if you will, for your map.
I got it.
We don't want to mention the
Oh, yeah.
I should have been asked.
No, it's fine. We're trying to make sure all our slides are in order, and we're drinking, and just keep yelling out questions, and we'll just have a good time. Really great question. In fact, one of the first things the question was, you have the background noise, you have the background reversed audio, and then you have the foreground audio with the 58 words. Why not try stripping out the background audio? Great idea. We tried that. We're like, all right, so one of my first ideas when we were working on this was, let's get every single sample of the background noise and do pass filters to pull it out, and it's a great idea.
Background noise does repeat.
Oh, but the great, great. Even more than being 58 words, the background noise does repeat. In fact, in multiple samples, I reversed all of them and listened to them in a row, listening for repeats, and they do repeat. So you
different places.
Different places. So like if you noticed in the previous sample that someone was talking about failed to keep it open or struggling to keep it open, you might hear that several times in different samples. The tough part is though, there's 3 simultaneous instances of that background noise at the same time.
We're not really good at
And I'm not good at audio. In fact, I'm not good at anything. Like I'm really surprised that we're standing up here right now. hang on, guys. We'll have questions at the end. We're drinking. You just chill out. What was I going to say? Oh yeah. So it turns out, great question.
That's a really hard thing to do.
First of all, really hard thing to do. Second of all, at some point we're like, you know what? Let's just try ignoring it and not worrying about it.
That's what humans do.
And that's what humans do. Turns out it works really well. So untangent to the untangent, untangent to the untangent. Back on
Pop the
topic.
stack 3 times, and we're back to me where, so yeah, use lots of backgrounds, backup solvers if the first one doesn't get a high enough certainty for you. So yeah, moving on. Ding.
Back to me. So really interesting. Like we've heard a lot of great, interesting tech about the neural networks. This is really fun kind of linguistic stuff. So we have 58 words. For instance, blue. And I started thinking about this. How would I spell the word blue? Because there's multiple ways to spell it. You have B-L-U-E, you have B-L-E-W, you have B-L-L-O, B-L-U. Not generally accepted spellings of the word blue, unless you're on Facebook. But or French. But they all. How could they distinguish? Like, what is the proper spelling for the word blue when there's so many different ways to spell it? And we found that it doesn't seem to be spelling based. It seems to be phonetics based. So kind of like a Soundex algorithm, if anyone's familiar with that. As long as it pronounces the phonetics and your response has the phonetics, it is a validated answer. Your CAPTCHA is solved. Is the next one?
Ding.
Yep.
Yeah.
I don't remember.
I don't remember.
No, you hit on.
That was the wrong way.
I am smart. I am smart. S-M-R-T. I mean S-M-A-R-T.
So even beyond having how different ways to spell words, we figured that sometimes vowels just don't matter. In fact, you can spell spoon, spooyown, and it's a validated CAPTCHA. What the hell's going on? That's a very interesting way to do things. So we're like, all right, let's try removing the O's. SPN, validated again. And I found the Thursday GIF like 3 days ago, so I'm really happy with that. Thursday!
Would be accepted.
So, and in fact, Thursday would be a valid Thursday. Because of another interesting thing, which is on the next slide, I believe, you can kind of stretch a word. You can kind of respond to it correctly, but really incorrectly as well. Here's the examples of what I'm talking about. You can actually forge words that are merges of valid samples and totally reduce the key space needed. So the ones on the right there, those are 3 different words that all meld into one response. Super fucking hilarious with that. So, for instance, for and fork is a word set that is very commonly mistaken by any matching algorithm. It's really hard to tell it apart. Luckily, we have fork, and fork matches both of them. So who gives a fuck? Well, actually, we tried spork. It doesn't work. Yeah. Well, so another one, oven and seven, very hard to tell apart, and soven, just matches both. Teaspoon and spoon. Now we're getting into some interesting territory. Well, spoon obviously matches spoon, but TS, as in tsunami, also matches spoon, but it also matches to spoon, which is close to teaspoon. So this got me thinking, it's almost like it's contextually trying to force the word to be right for us.
Yeah.
Fuck yeah. And what's really funny, do we go over the automated stuff?
Yeah, that's
All
nice.
right, so the three furs on the right hand, fantastic. The top one, van and wagon, this is actually a second version of that merge. The first merge was another really great merge. It was a twofer between van and wagon. The spelling, now it's three. I'm talking about the two is the fun one. The spelling for the twofer merge between van and wagon was V-A-G-N. Silent G with the N, so you have van. We also have wagon. That's pretty damn close to wagon, so it matches both. By the way, we reduced the key space by about over 50.
On the next slide.
Oh, we modified slides today.
Yeah.
Brute forcing merges.
2 slides. Sorry.
Is it?
Yeah.
It's not on there.
Brute forcing. All right, you're good. Keep
Brute
going.
forcing. So the three furs I said before. Initially, we hand validated all the merges like for and fork. Like, well, let's just fucking try that. Like, if we stretch a word down, stretch a word up, and really fun to find that trick. So reducing the key space, fantastic. But we only had like 16 merges, and we wanted more, because more merges means lower key space, means higher accuracy. So we built a fully automated brute forcing merge finder, and it spit out dozens of them in just 24 hours. We were really surprised it worked. In fact, it was what allowed us to find the three for merges. Very interesting. It will download a sample, pick 2 words at random, Levenstein distance them, come up with a new string that is a small distance between the parent strings, and just arbitrarily submit it. And if it comes back correct from Google, we're like, oh, cool, that worked. Excellent, save it.
It's only 5 words.
It's only, so 5 out of 6 words. When you want to do word verification like this, you actually just don't respond on the 6th word. So you're like, oh, the words were boat, blue, table, kettle, kettle's rocket. And we just don't give train. We don't give train. And then we pick one of those 5. If it comes back right, we have a merge. If it comes back wrong, we don't have a merge. Really fucking fantastic stuff. So, fantastic. All right, so now, at this point, we have so many merges that came about from the brute force merge finder that we have multiple merges for multiple words, as in we have blue and bike, we have blue and black. Well, which is better to use when you have blue? When your top rated response from the neural network is blue, I'm 80% sure it's blue. What about the other fucking 20%? We want to make sure we have that solid. So we invented contextual merging based on certainty. So the neural network spits back its top 3. I'm 80% sure it's this, 20% sure it's this, and 0% sure it's that, because I can't do percentages in my head. So, 110% certainty. But it takes those top words that the neural network chain thinks it is and says, do we have a merge for these words in our database? We do? Cool, use that. So even if we're 80% sure and we get it wrong, if it's right on its second guess, we get it right. If it's right on its third guess, we could get it right. So even when we're wrong, we're right. And when we're wrong again, we're right. Good stuff.
Ding.
Ding.
Oh, that's
Adam?
So we wanted to see, actually, I came across some research on audio-based CAPTCHA systems in general, just haphazardly. It was not, I wasn't going out and looking for it. I was looking for something else at the time, which I eventually found. But I came across this and I'm like, well, that's interesting.
That last point's not valid.
And
not anymore.
Yeah, okay. So we found that there were 2 different, okay, so there's an old audio CAPTCHA system before what you heard today, and it only had 2 voices, and it only said 10 different things total. It was the numbers 0 through 9, and that's it. So if you were to randomly guess the answer, you'd be right 1 out of 100,000 times, just randomly. This is the system that the other people attacked, the universities. That's not what we went up against. The new audio system, like we said, had 58 words, so if you were to randomly guess, you'd have 1 in 38 billion. That's different odds than 1 in 100,000 for any of you who aren't good at math. Yeah, so we had, it's apples and oranges, right? But no one, we haven't found anyone who had attacked the new system. We only found people who attacked the old systems. Up until today, the old system was still available if you had no script. So instead of hearing boat and kettle and rocket and so on, you would hear the digits. That's no more. We'll get to that. Okay, so how did these universities fare? Stanford tried it in 2011, and they tried a whole bunch of different audio captchas. With reCAPTCHA specifically, they got 1.52%. They weren't so good at it, but they put forth that if you have a botnet, 1 out of 100 tries, if you have a lot of tries, then that's, okay, that's reasonable. I disagree. So does Carnegie Mellon, who got 58%. Again, this is the old system, so, take it with a grain of salt, but, so this is the point in the presentation where we were supposed to say, oh, look at our live demo that was running and see what the accuracy was. Turns out, they changed their shit, so we couldn't do that.
Yeah, here's
but
a video.
Here's a video of our system running in the past.
This was like a week ago.
If you've never been burned by the demo gods, you don't know what just happened, but we pre-made a video. Learn. Don't make the same mistake. Do a live demo and have a video backup.
Correct.
So here's Selenium, which is a great interface for browser stuff, actually using Stiltwalker
Correct.
to use
Correct.
the DOM interface to fill out reCAPTCHA. And as you can see, it's a little bit slower, but it's just pinging through it, correct. And it's just kicking along. So that's pretty awesome. Next slide. Oh yeah, explain Selenium, because that's just awesome.
Selenium is awesome when it works. So it pulls up Google's demo page for reCAPTCHA, and then you've got to hit the little button that says "Give me an audio one." Then it downloads it, solves it, or splits it, solves it, then puts it back in, hits the submit button, and then you get to see whether you got it correct or not. And so we parse that text.
It's a plugin.
Yeah, it's a plugin for Firefox, and they have it for Chrome. It's pretty awesome.
And IE.
No.
Yes, they do.
What's IE?
Yeah.
How do
What is it?
How do I install that in Linux?
And move on.
Anyway, it's a little bit slower than just doing it in Bash. Right now, the network part is about 0.5 seconds to download and then later submitting it. And our solver does it between 0.3 and 0.5 seconds. So by comparison, to listen to it, it used to be 8 seconds long. So if you were a human doing it, you could do it 1/16 the speed that we could as a computer.
The network speed is actually the biggest bottleneck in solving this. The neural network is stupid fucking fast at solving this.
Well, I guess it's too late.
Oh, well, and by the way, that's our accuracy.
Yeah.
Was. So we didn't just a little bit break it, we really broke it. Our hasty slide manager pulled that up. But yeah, so 99.1% as of last night, we pulled this, and this morning. So here's the fun thing. We had been in the 90% for a little bit, and as you start making any system more accurate, it becomes really harder on a just insane ramp to gather that last little bit of percentages. And as we creeped forward, I'm like, there's no way we could get more than 92%, 94%, 97%, 98%. Shit, I'm just gonna stop saying we can't do it because it keeps going up. If we get 99%, I'll buy a bottle of Johnny Walker Blue Label and we'll drink it on stage. Guess what we're drinking? Because it fucking happened. So we actually started one of these training sessions because it takes a good amount of time to train the neural network. After you spend a good amount of time manually validating all the samples, good amount of time. So we're partying last night in the karaoke room, whatever the hell that place is called. We're drinking, having a good time, and we're like, all right, cool, the neural network's training, we'll check it out and pull it up, and holy shit. Yo, guys, we just broke 99%, is what I hear from Jeff Ball. That's fantastic. So this guy and me 2 nights ago stayed up late and validated a whole new methodology for creating neural networks for the samples that go into it, just to try and get the last 99%. So the last ditch effort, the last minute, the 11th inning, we nailed 99%. So that's why we're drinking Johnny Walker Blue Label. Woo! By the way, we're now 0%. I want to take a quick moment, like right in the middle, because I told you I'd go off script, and I'm going to go fucking off script right fucking now. Kudos. Well done. Well played. No, I mean, yeah, he's angry, I'm angry, we're all angry, but well played. So, at DEF CON, you fuckers need to be there, and we'll have shots. And it's not over. Game on. The game is afoot. Where's my table? I need to flip my table.
Your table has left the building.
Don't flip the table with the beer on it, or liquor on it.
All right,
Okay.
do your thing.
Anyway, going back to script. So an interesting thing happens when you're trying to break reCAPTCHA.
Hard.
If you get below 60%, he will flip a table. Anyway.
Hey, we're not throwing chairs, okay? We're cool.
Do you have a chair? I'll throw it.
Only like 2 people get that joke.
Yeah, well. What are you gonna do?
I got it.
So if you get below 60%, then you get rate limited. You get
No, you get banned.
no, you don't get banned.
No, it's an hour ban. It's a 10 ban. 10 ban.
All right.
You're drunk.
Screw you guys. Anyway,
Full drink? Look at this asshole. Break. There we go.
Blue Label.
good stuff. It's chug.
It's nice.
So, when you're doing the audio captures, apparently they think the image ones are harder. So if you get below 60% on the audio, they make you do the image. And normally with the image, you can get a couple letters off, and you only have to get one image right. But if you get below 60% and then get temp banned, then you have to get the image exactly correct with both words. And so that was a problem. And so below 60%, it sucked because we'd have to start testing it, then switch IPs, and then start testing it, then switch IPs. And you'd have to continually do that in order to get your accuracy. But after we got above 60%, they must think we're human because they don't rate limit us anymore when you're getting... What?
Universities, for example?
Yeah.
Oh yeah, like universities, but 60%, when you get above 60%, they're fine with just giving you as many as you ask for. And so...
That's the money.
You must be human. You're solving it faster than it takes the audio to play.
That is a shitty Turing test.
Yeah, or we are as human.
Ding.
Ding. Oh, and this is my favorite part.
Well,
So, when we were doing this, we thought, they wouldn't possibly give us the same sample more than once.
exact same.
But they give us the exact same sample more than once. It's just on a very large scale. They have between 20 and 25 million CAPTCHAs. So over a long enough scale, you get duplicates. So you just need to download and solve a lot of them, like 15 million. So we downloaded and solved 15 million. And that was just how much our servers could do between when we figured that out and now. I mean, it's an asymptote, so they're exponentially harder. So as we got to 15 million, it gets harder and harder to get unique samples. So when we first started off getting samples, we'd get a unique one every time. But at 15 million, you only get a unique one 39% of the time. So if you just use that lookup table of MD5s that we have, you get 61% accuracy because you just look in the file. Is the MD5 there? Yep, submit it. And then you get 61% accuracy. And rather than taking 0.5 seconds like a neural network would, it takes 0.005 seconds. So, yes, and it's always right because we've already submitted it once before and it was right then.
65% of the time, 100% right.
So if you're going to have a CAPTCHA system, you should not give out the same CAPTCHA more than once. No, there's still other points. All right, so one thing, I will ding when I want to. So the one thing we don't know is whether they pre-generate it or it's done on the fly. We don't know if one time they generated all 20 to 25 million CAPTCHAs or they only have 58 words and they only have so many background noises, so they just generate it, but there's only so many combinations, so there's only so many CAPTCHAs. And so we're not sure on that. My guess is they did it on the fly because nobody would be that stupid to pre-generate it, but then again, nobody would also, not include the frequencies of the words in the background noises, but they did that, so who knows? Anyway, ding. Oh, and so this is the fuck you Google part of the presentation that I added like an hour ago when we were sitting around trying it. But this is how the spectrogram looks prior to 2 hours ago. You can easily pick out the 6 words. It's pretty easy. You can see them. This is how it is as of 2 hours ago. Yeah, so we gave this a version of this talk, a slimmed version of this talk at Outer Zone, and so, yeah. But it makes it slightly harder to split. We'll see how it goes when we get time, and we feel like training a lot more sets.
Can you see the words there? Kind of.
Yeah.
So if you can see the words here, 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 there's 10. Yeah. Ding. Yeah, there's now 10 words, not 6. We don't know how many you have to get right. I tried as a human to try and solve some of these. I got about 1 out of 3 right. No, this is before I was drunk, sir. Yeah, this is sober and with an accomplice.
This is how we make better humans.
So before it was 10 words, before it was 6 words, now it's 10. Before it was 8 seconds, now it's 28 seconds. And humans went from, I would estimate humans would be at least 70% with the old system.
I would say 80%.
80%, thereabouts. Now we're, now the new system with actual humans who have studied reCAPTCHA for the last 4 months are getting 30%. Basically, they broke their own product. Like, yeah.
And one other thing is this might, and there's a couple people saying this, I don't know if it's true, we don't know if it's true, but they might have just implemented a shitty version of reCAPTCHA to fuck with us in our talk. And then, meanwhile, they're scrambling to try and fix it. Could be, could not be. I don't know, we don't know. But we're looking forward to the next round of this, because we're going to get you guys. And that's all there really is to say about that. But drinks in Vegas, seriously.
So I'm just going to play the old version versus the new version, if you want to listen to it.
Vote. 4. Carry. Wednesday. Cup.
So that was the old one, and let's see if you can tell the difference between the new one. And it goes on for 28 seconds worth, but I'm not going to make you listen to the whole thing. Yeah. And so the two of them tried to do it like legitimately as humans who have, studied this for the last 4 months. Yeah. All right, it just finished right now. But they tried to do it as having just done CAPTCHAs, audio CAPTCHAs for the last 4 months. And they got 2 out of 5 or 2 out of 6. And so I'd like to see what normal people who haven't studied it for the last 4 months could do. But essentially, if you're blind, then you're not going to. Oh, sorry. His question was, so it's essentially useless.
Yeah, he said, isn't it essentially useless? And the answer is yes. Next question. Maybe if you get it right inside your computer. That's possible. It said correct when I typed it in right with my fingers, but maybe, I don't know. Next. Yes, we've tested this from my home, his home, this local place, Tor, 4G shit, like all that, and everyone's getting the same version. So, This? Bandpass stuff? Yeah, well, we'll see. Look, we just found out about this 2 hours ago. We are working on it. We're on the case. Yes, you, with the beard. I want to hear your question, sir. Please, speak up.
To that end, that you are working on it, are you sure you don't want to wait a week because it is functionally useful?
Who the fuck cares? Are they gonna break it again? We'll break it again.
Well, no, I mean, all I'm saying is,
This game is more fun. We broke it. We'll break it more. Terrible idea.
Okay, so the question was, do you want to wait a week to break it? Maybe. Maybe we do. Maybe we don't. I don't know. We'll see. I'm not gonna. Hey, hold on. I'm not gonna give them the advantage of telling them whether or not we're working on it. So yeah. Okay, I'm going to address the second part of this question here. Okay, so the question was, why don't we just slice it based on phonetic parts, so f or I or or k. So yeah, just right, thanks. Yeah, I'll drink to that. So the question was, why don't we base it up on every phonetic section instead of the whole word? We're working on it. That's a good idea. It turns out we're not so good at audio processing. We just kind of like try stuff and see if it works, and turns out, well, 99% working as far as I'm concerned.
I'd like to point out that we're not experts in anything. He just learned neural networks. I have no knowledge at all about audio anything, and this guy is like Honey Badger. He just does not give a fuck. All right. We just were like, let's fuck it up and see what happens. And then 99% later, here we are. Oh, more to say. Huh?
Okay, so again, getting back to the countermeasures after tangents. There's new words. Now there's island and October, when those weren't words prior to an hour ago. Butterfly is a word as well. But, well, they did it an hour or 2 hours before the talk, so it kind of makes me think that, hey, we should change this to mess with them. Yeah, fuck that. Anyway. Oh yeah, the background noises, they used to be public radio backwards run through it. Now they're actual English words, just at a lower volume. So while it's playing, they say the word pink forward, and you can hear that, but if you type it, it's wrong. So that's a little... Yeah, it's also, the actual words are longer and on a slow tone, whereas the background words are high tone and they say it real quick. So they'll say pink, versus when it's in the actual word, it's pink. And so that might be one way we do something. That it is. Oh, and if you didn't notice from the last slide, they're also the same frequency of the background words are now as the actual words. So they apparently saw this and said, we probably shouldn't do that.
I've got an idea. I've got an idea. I'm going to pitch it, because fuck them. We're going to beat them anyway. Or we're stuffing our feet in our mouth right now. One or the other. But because the words are much slower, like fork, Saturday, that's a lot more data to feed into the neural network. And more data typically means more accurate. Just saying. Yeah.
I got two questions for you.
Fine, go ahead.
Acid neural network. First one. Since you've done all this slave labor, you're gonna release all this labeled capture.
Oh, hang on. Whoa. You're getting ahead of ourselves. Yeah, we'll get back to that. I saw another hand, because why not? Let's do it right now. Yeah. Sorry, one more time. One him, and then you.
So you've heard of things called Open Smile framework.
Open Smile Framework. I've never heard of this. What is this?
It's all audio features, so you don't have to think too hard about this fast forward transfer or anything like that. You got like 40 of them. I can read them off to you later.
All right, we'll talk later. Why not? Any? Yes, you?
We use stocks instead.
Socks. Yeah.
So anyway, I'm sure it's not nearly as accurate as what you've got, but
No.
there's the audio recognition software has an API framework. Was it?
Oh, so here's what.
Have you compared it at all?
Well, here's the cool thing about that. And no, we haven't compared it, but I mean, one of the things we realized early on is that if you're trying to create a audio captcha where there's a human voice speaking, how would you develop a system to throw off automated, phonetics detection in like what you're talking about, speech to text kind of things? How would you do that? The background audio is still human voices, so it throws off whatever is trying to analyze it. And that's just a guesstimate because we didn't actually fucking try it. But that makes sense to me, right? Like, does that make sense? Kind of, yeah? Yeah. Yeah, no, we did. So the Google Voice has speech to text for the Chrome plugin. So yeah, so the question was, have we tried using their own tools against them? And the answer is, fuck yeah, first thing I tried. Because they've got a speech to text plugin system for Chrome, and the first thing we did was like plug it into that. Like, does it work? And the answer is hell no. And another interesting thing, the former words, the words that we worked on, it seemed to use the exact same text to speech system as Google Translate. So if you walked over to Google Translate and typed in the same words and popped them out, the waveform was remarkably similar to what you were getting out of the reCAPTCHA system. So we know within a general, reasonable amount of doubt that they were using their own text-to-speech systems to generate the audio. So we tried things in the beginning like doing pass filters on same words, but ultimately we just ignored all the background and just trained on the garbage, and 99% later.
So if you think about all the things that we used to beat the system, it was the splitting was a key part of it, which, as you saw by the spectrogram, it's much more difficult now. Yeah, that's not so easy as ding, other way, anti-ding. No, it's not registering. There we go. Not quite as easy as this. So they've made it a lot more difficult for us. They've also made it a lot more difficult for humans, and I don't know if people will accept that. People like Twitter and Hotmail. I'm just saying. CNN, forums, 4chan. Moving on. All right, so yeah, no, go back.
Just saying. It's the most unorganized presentation ever, but fuck it. One thing that I actually wanted Jeff to cover is what we didn't cover before is how we accomplish the basic splitting for the entire column.
Okay, so we go through, we start at 170 pixels in after we remove the border, which is right above where the background noise is, as Adam is pointing.
You can't see it. You're not over there.
I know, but that's why I said Adam. Shh. Adam pointed to it, and we start there, and we keep going until we get to a non-black pixel. Then you keep going until you get to a black pixel, and that's the column. But it turns out you include a lot of extra stuff, and sometimes when the words are closer than this is the ideal case, spectrogram. A lot of times 2 columns are right next to each other, and so you don't know if that's 1 word or 2. And so you'll have to go through, and I start from the top, and the code goes down, and it tries to find the point where there is a non-black pixel. And so yes. Anyway, it starts at the very top once it's got the words that are untrimmed, and then it goes downward and sees how far down it can get before it gets a non-black pixel. And if it gets below a certain threshold, then we know we should trim that. And if it gets above that, then we know that's part of the word. And so, you did a very poor job. Anyway, that is how the splitting algorithm did work, but I mean, obviously, that's not really going to work now. Yeah, don't. That's not going to work. But anyway, continuing on from the slide we've been on for like 15 minutes. Oh yeah, code release. Yeah, getting back to his question, everything has been released. The MD5 list, which was an MD5 of 61% of the CAPTCHAs, that's pretty much pointless now. So they changed them all. Before it was like the greatest thing ever because you needed to write zero. You needed nothing to get 61% right because we already did it all. But now it doesn't even matter. The theta values, we have our best one, and then there's every one we tried. What? Oh yeah, the theta values are what the neural network needs in order to take a sample and decide what word it is. We have all those, but once again, they're pointless because they were trained on the old set of words, and so if you feed it the new one, it's not going to give you the right answer. We have all our code, which is, it's done so that we could add new solvers and new splitters so that you could add additional functionality, such as when they changed it in a week, or today. We thought it was going to be a week, but they changed it like today. So we'll add a new splitter and a new solver to it, and it'll continue going. And so that's we set up a Ubuntu repository, and then there's also a source tarball. If you go to that address, which is just dc949.org/project Stiltwalker.
If you can find any way to get to the old system, let us know. We will be very happy, and we will share it with everybody.
People, the few people we've shared this with are mostly saying, "Why aren't you guys selling this? Why aren't you guys making money? Why aren't you guys, like, fucking sell it?" Because that's not fucking fun. This game with the, because we're not sellouts, man. No, this game with the developers, it's gonna keep going, and this is just the next step. It's been fun. It's gonna get a lot more fun. I'm the white knuckles. You gotta help me out here. I'm pissed off. I'm excited.
We're going to keep going until we win.
To answer whoever said they wanted the corpus for it, it's like 2 gigabytes. Yeah, fuck you. It's 2 gigabytes, and we'll release it. I'll put it up later.
So all you assholes who had questions before, now is the time you're supposed to ask them. You, in the green and with a beard.
Yes, have you gotten in contact with any linguists? Because it seems to me that you could use a linguist in this sort of thing.
All right, the question was, have we talked to any linguists? And the answer is no.
You should!
We should, yes, I agree. Are you a linguist?
No, but I know some.
All right, well, hook us up.
Will do.
Done. Next question. You, sir.
Okay.
Super fast. Yeah. Just stupid fast. Yeah, probably.
All right, so the question was, we were going through these super fast, like 0.5 seconds per CAPTCHA when it takes 8 seconds to play the CAPTCHA. And the question was, do you think that this is why they, found you out?
So we've had about 90% for the last 3 to 4 months. Yeah, 90% accuracy for the last 3 to 4 months. And so you'd think they'd change it prior to that because we gave a preview talk at Outer Zone. And so they did not. Yeah, I don't think that our tiny amount of traffic compares to our semi-tiny amount of traffic compares to everybody who uses reCAPTCHA.
Tell them how many
Oh, yes, and we did, my one server did about 300 to about 500,000 a day. And plus CP's server which did at least 500,000 a day. That did 800,000 a day. And then I had another server that did about 200,000. My laptop did 100,000. His server did 400,000. So we're approaching 2 million a day. But that's nothing compared to all the forums that use it. Twitter uses it. All right, maybe. So the next version that tests our accuracy may just be on one of reCAPTCHA's clients that use it. Yes, because then they won't be able to tell.
Just use 4chan.
We were trying to be nice, but, well, fuck it now.
I don't know if this is real or not. Hang on. But we did notice one strange little funny thing that happened while we were testing very early on. If Jeff Ball's servers were harvesting, accuracy, and my servers were harvesting accuracy, we'd notice something strange. As in, network lag would increase drastically for both of us. But if only one of us did it, then it'd be fine. We realized that it was possible that we may have been accidentally denial of servicing the demo page betwixt the two of us. Honest mistake, didn't mean to. Seriously guys, drinks in Vegas. But then that went away, so maybe they upgraded their hardware and went, what the fuck's going on? Or they, just flipped a VM switch and made it faster. I don't know.
Bottom line is, did we get caught because we were very aggressive? Maybe. Although, they did change their system like 2 hours before our talk here. So, maybe not. Next question.
The question was if we were just downloading the challenges or real-time solving them. So you go to the demo page, that's one GET request, and they give you back the challenge ID and the link to the audio. Then you get the audio link, you pull it down, so that's an audio download, that's another GET request. Then you solve it and you submit it, so that's another GET request. So all in all, it takes 3 GET requests to submit a CAPTCHA to see if you got it right. Oh, POTE? So the question was if us submitting POTE for boat and plate and the other word that it matches, tip them off. And so maybe. Oh, we did have an option to not use word merges, but we didn't use it because we wanted to see the highest accuracy we could get, and word merging helps. Yeah. Question in the back?
Does word merging still work on the new stuff, or have you guys not had time to test it?
They just changed it. The question was if word merging still works on the new system. So we don't know how many words there are. We found out this while we were testing our demos for right now. Yes, and so when we saw that, we were table flipping at the point.
I tried getting a couple of these right as a human. Like, I just wanted to use their service. And I got about 1 out of 3 right. We actually had syntax error helping us out, and we were like, oh, that was this word. Oh, I didn't get that, but you did, so I'm going to answer that. We couldn't do it. So, chances of them changing their system very soon is high. Yeah, so next question. No. Does it drop back to an easier version after so many times of getting it wrong? The answer is no. No, it doesn't. I wish it did. Blue shirt.
Did it change everywhere or just on the demo page?
Did it change everywhere or just on the demo page? Well, we thought of that too. Turns out it changed everywhere, which is very unfortunate for us and very fortunate for Google. And it sucks for any blind people, not deaf people. Blind people. Yeah. British guy. Yes! Why are we drinking Coke and Blue Label?
Thank you! Because Coke and Blue Label is fucking fantastic. If you've never had a Johnny Walker, Blue Label, and Coke, it's fantastic. For 2 reasons. It tastes really good, and it pisses some people off. And if there's anything I like doing, it's pissing people off. and tasting good. Speaking of pissing people off, the reason I'm not extraordinarily pissed off about the being countermeasured, he is really mad. I'm frustrated and excited, but there's one reason alone why I'm not super pissed, and that's because that is exactly what I would have done. If they were giving a talk on something they fucked up and I knew about it, I would have fucked them up the hour before it, and they did it to me. Kudos. I'm excited for that.
I second that. Plaid man.
Aren't you guys extra successful because you got them to break their system?
All right, so the question was, aren't we proud of being extra successful for breaking their system? I am, personally. I think my colleagues are as well. Thank you, yes. Well, I am a doctor. You know, I am esteemed. So. This. This comment does not count. We're done. Next. All right, so we broke reCAPTCHA. The bottom line is, we broke reCAPTCHA 99%. They fixed it on the day of our talk, which is a dick move, and it would have been the same thing that I would have done if I was in their shoes. But yeah, so you can get our code if you want to download it and make it better and make it work for the new system. Basically, all you need to do is find a way to split it, and then just solve some stuff manually and retrain it, and you will have broken reCAPTCHA. I guarantee it. Sir?
Call up some lawyers and file an ADA complaint.
So one of the countermeasures that we had thought about when we were thinking, what would you do if you were Google, was we thought that they would just, after our talk, because we didn't envision that they would know about it and change it an hour before, we thought that they would just leave it up, and then all of a sudden everybody gets our code and then starts attacking reCAPTCHA. And so we thought they'd just take down the audio version. And so then we were ready to, if they took down the audio version, file an ADA complaint. But they just changed it instead.
So one of the other things that I had planned was to send an email to the Stanford people who got 1.5% and say, hey, you should take this machine learning class from the Stanford professor and learn how machine learning works and win, like we did. And I was also going to email the Carnegie Mellon people because the lead person of that endeavor said, oh, I made reCAPTCHA on her resume. She said that she made reCAPTCHA in secure, basically. Secure against automated attacks. Thank you, CP. We made sure that no one could do automated attacks against the system because we did all these different things, which, as we look at them, I'm like, hey, that was a really good design plan, but we still beat it. I mean, that doesn't change anything. They made some good decisions, just not good enough. And we're going to email all those people in one single email saying, hey, good machine learning class. You should take his machine learning class so you can win. And I know you think you secured it, but you didn't. All in one email. And they just stole my thunder because Google updated their shit. And now I got to break it again before I can send an email. So, yeah, that's what I'm doing now. Next question.
Any questions? Because we want to go drink and be done with this.
Yeah.
So, anything left?
I am drinking now.
Yep.
Yeah.
The original one?
Yeah, that one. Right. So when you pass filtered it, I'm sorry. The question was, why didn't we just chop off the bottom half and only analyze the top half? And we tried that, and in all fairness, it probably would work. But I'm just saying, like, ultimately, results speak for themselves. And 99%, if you break a CAPTCHA system with 1%, it's considered broken. If you break it with 30%, that's considered destroyed. It is fucking unheard of to break it with 99%. What the fuck am I going with this? I'm fucking drunk. Oh yeah, I got a phone. Hang on, I gotta take a phone call because someone calls me on stage.
That's Jeff Ball.
It's overdose. Shut up.
So we thought about splitting, and we even tried splitting on the 170 pixel, which is the part where just the words are. But that little orange part at the very bottom is extremely important to the spectrogram, so, and to p-hash it. So we decided to keep that. Yes. So when you're looking at trying to pick out those words, you need that part right there. So we tried it because basically our methodology was, let's try everything, and whatever works, we'll keep doing. And so we tried, only using the top part of that picture, but it didn't work.
Let me just put it this way. We're not done trying to beat reCAPTCHA. We have a lot more ideas in the works, and thanks to CPFR, we have a new library to look at, and there's a lot more work to do. Yeah, a linguist, a clever one. And
no, they're cunning.
Let me put it this way: we're not done. We have a lot of ideas. End of line.
End of line.
I feel that you should clap again, quite frankly.
I do have one last thing to say, and it's concerning LayerOne, not Stiltwalker. We love you. No, DC949, at least a good chunk of us, we gave our first talk here at LayerOne. And when we realized that Stiltwalker was going to turn into something a little bit bigger than we planned, like we were just fucking around on the weekends and nights and having fun, and it turned out to be fucking hot sauce and epic. And as I like to put it when I describe it to people, it's tits and booze kind of sexy. Tits and booze. And I figured, where's the best place that we can give our tits and booze kind of talk? And that place is LayerOne, because we have a special place in our heart for LayerOne. That's all there is to it. This is it. This is it. This is where it's at.
Okay. Well, thank you, DC949. As soon as the next speakers get set up, we'll have Mangling with Botnets by two very fine gentlemen. So stay tuned.